In this video, we're going to calculate the number of protons, electrons, and neutrons in an atom. Let's start with fluorine, which has a chemical symbol F. Here are the information we pull out from the periodic table. You should see at least two numbers. One is a smaller whole number, and the other is a larger decimal number. In the case of fluorine, the smaller whole number is 9. That's the atomic number, abbreviated as Z. The larger number, 18.998, that's the atomic mass, abbreviated as A. When calculating the number of protons in an atom, it's the same as the atomic number. The number of electrons is also the same as the number of protons as long as it is for an atom, which is neutral. For the number of neutrons is the atomic mass minus the atomic number. Keep in mind that the number of neutrons should be a whole number, meaning no decimal points. Let's figure out the number of protons, electrons, and neutrons for fluorine. You might want to pause and calculate on your own first. Okay, for number of protons, it should be the same as the atomic number, which is the smaller number, right? So that should be 9. Since the number of electrons is the same as the number of protons, because we're calculating for F atom, it should be 9 as well. As for the number of neutrons, it's the difference between atomic mass and atomic number, so that turns out to be 19 minus 9, and that's equals 10. Note that it is not 9.998, instead it is 10, because, like I've mentioned, the number of any of the subatomic particles, protons, neutrons, electrons, they should be whole number. Whole numbers are like 1, 2, 3, 4, 5, so on and so forth. No decimal number. Let's move on to another example. Let's say the question gives you uranium-235. What does the 235 means? That's actually the atomic mass of a specific isotope. So if we look at the periodic table, this is the information we will get. The smaller number, 92, that's the atomic number. What about 238? Well, that's the average atomic mass. Let's figure out the number of protons, electrons, and neutrons for uranium-235. You can pause the video while figuring out on your own. Okay, so the number of protons is the atomic number, which is 92. For a neutral atom, the number of electrons is the same as the number of protons, so therefore it's also 92. And for neutron, is the difference between atomic mass minus atomic number. Notice we're going to use atomic mass of this specific isotope, so it's going to give us 235 minus 92, and that is going to be 143. If you got 146, you must have taken 238 minus 92. That's a common mistake. The reason it's wrong is because this example is asking us to find the number of neutrons for uranium-235 isotope. Therefore, you're going to have to subtract it from 235, not 238. Moving on to our third and final example, 14N. That 14 on the top left of nitrogen is the atomic mass of nitrogen. In other words, we need to find the information for nitrogen-14. Similar to the previous example, since the atomic mass of the isotope is already given, that's what we're going to use as our atomic mass. So we pull out the information from the periodic table for nitrogen, and this is what we got. And it looks like isotope 14 is the most stable isotope since the average atomic mass is pretty close to the value of the isotope. So the number of protons and electrons is going to be 7, and the number of neutrons is going to be 14 minus 7, and that gives us 7. If you're looking to calculate the number of electrons in an ion, be sure to watch out for the upcoming video. To recap, for an atom, which is neutral, the number of electrons and protons are the same, which is the smaller number in the periodic table. The number of neutrons is the atomic mass minus atomic number, meaning the larger number minus the smaller number. If the question is asking for a specific isotope, be sure to use the given atomic mass for that isotope. Last but not least, the number of protons, neutrons, electrons, they should all be whole number, no decimal points. Hope that was useful. Do subscribe, and thanks for watching.